Now let's review working with fractions. So we're going to quickly review how you add, subtract, multiply, and divide fractions. This first paragraph here is just a description of what a fraction represents with respect to division. I'll let you read through that if you need to. Let's start with this first rule of multiplying fractions. That's actually the easiest rule to follow. So if we're given two fractions, a over b and c over d, to multiply them, all we have to do is multiply the numerators together and multiply the denominators together individually to get the fraction a times c divided by b times d. That's all you have to do. Now I don't have it written as a separate rule here, but if the one value like a over b is a single number, just like a, so if you have a times b divided by c, that's the same as a times b over c. You just multiply the number into the numerator of the fraction, like that. And the reason that is because it still follows this rule. You think of the a as being a divided by 1 times b over c, and then you follow this rule. So you see you'd get a times b over 1 times c is just c. There you go. And if you've ever wondered why do we multiply fractions together, well, just think of this little example. If you have 1/2 of 1/2, what is 1/2 of 1/2? That's what multiplication represents. Well, 1/2 of 1/2 is 1/4, right? And notice that we recover 1/4 if we just multiply straight across, right? So that's why we multiply fractions. Just think of that little example there. Now let's take a look at a few examples down here. So let's simplify 3/4 times 5 over 7 by hand, and let's also use a calculator. So all we have to do in this case, you just have to multiply straight across. This is just going to be 3 times 5 over 4 times 7, and of course you just get 15 over 28. And that's it. Now to evaluate this on a calculator, so we just have to take 3 divided by 4, 3 divided by 4 times 5 divided by 7, like that, and we will get back we get a decimal back, so let's just check that it is the same as 15 over 28. If we evaluate 15 divided by 28, we get the same value back, so yes, we did that correctly down here. Now, some people wonder, do you need parentheses around the 3/4 and the 5/7 when you multiply them like this? No, you don't, because the order of operation works out fine in this case. But once again, it wouldn't hurt if you did use parentheses. If you went parenthesis 3 divided by 4 times parenthesis 5 divided by 7, if you use the parentheses even if they're not needed, you of course will still get the correct answer. But in this case we don't need parentheses. Now when we divide fractions, well, then you will need parentheses. Now let's take a look at canceling terms in a fraction. So if you have a fraction like a times c divided by b times a, you can actually cancel those a's. Just replace them with the number 1, and you get c divided by b. For example, let's simplify this. 15 over 24. Well, 15 is 3 times 5. And let's see, 24 is 3 times 8. So you just have to look, does 24 have a factor of 3 or 5 in it? Yes, you can write 24 as 3 times 8. Now we can cancel the 3's, right? And you're left with 5/8, 5 over 8, or 0.625. Let's take a look at this one. Now here's one with a variable in it. Let's simplify 8 plus 2x divided by 24. So if we have so we want to simplify this. Now we talk about this down here in more detail, but you cannot cancel the 8 and an 8 in the 24. Since you have addition here, if you're going to cancel something in the 24 with something in the numerator, you have to cancel it with both terms in the numerator right here. So let's notice that we have a 2 in this term and a 2 in the 8. 8 is 2 times 4. And the 24 is 2 times 12. So if we write this as follows, we can factor out a 2 from the 8 and the 2x, 2 times x. And then the 24, that has a 2 in it as well, so we can cancel a 2 here. That leaves us with 1. And 24 is 2 times 12. If we cancel the 2 in there, we'll be left with 12. And then we have our answer of 4 plus x divided by 12. And so that's how this quantity simplifies. Notice how we think of factoring out a common factor in the numerator and then canceling it with a factor in the denominator. Now, you can just do this quickly in your head if you want. You don't have to go through this process we went through here. If you notice, we could just do this. The 24 is 2 times 12, so I can cancel the 2 in the 24 with a 2 here and a 2 in the 8. So we could just do this. This becomes a 12. That 2 becomes a 1. And the 8 becomes a 4 when we cancel the 2 out of it. Notice we cancel a 2 from this term and from this term. And you end up with 4 plus 1 times x times the number x is just x over 12. Then there you go. Now we mentioned something here about being careful when you're canceling terms. If you have something like 5 plus 3 divided by 3, this is what we just ran into in the previous example. If you have 5 plus 3 divided by 3, you cannot cancel those 3's. You cannot do that. If you tried to do that, you'd get the wrong answer. Notice that 5 plus 3 over 3, well, of course, that is 8/3, right? Okay, which is approximately 2.67. Okay, so that's approximately 2.67. If you evaluate that on the calculators, 2.666 repeating like that. Now, if you did, in error, cancel those 3's, what would you get? Well, you would get 5 plus 1 over 1. Well, that's 6 over 1, and that is 6. Well, obviously 2.67 and 6 are not the same number. So you cannot cancel the 3's in this case. The only time you could cancel those 3's is if this addition right here was a multiplication, or if the 5 had a factor of 3 in it. Like if you had something like 15 plus 3 over 3. Then it is fine to cancel those 3's. You'd have to cancel the 3 and the 15 as well. So you'd cancel this 3 with a 3 here and one of the 3's in the 15, leaving you with 5. And then you would get 6. And notice that that is the same as if you had 15 plus 3 over 3. 15 plus 3 is 18 divided by 3, and yes, that is 6. Okay, so you have to be very careful when you cancel. If you have an addition right here, you cannot just cancel one of the terms in the numerator with something in the denominator. You have to cancel something with each term in the numerator, like over here. So you just have to be careful. Now let's take a look at dividing fractions. When you have a fraction like a over b, and then that entire fraction divided by c over d, you think of flipping the c and the d and multiplying by a over b. So notice how you flip the c over d upward. You interchange the d and the c, and it becomes a over b times d over c. So that's how we divide fractions. So for example here, let's simplify 5 over 4 divided by 10 over 3. So we have to follow this rule up here, so that's going to be 5 over 4 times, now we flip the fraction in the bottom and multiply against the top. So this is going to be times 3 over 10. Alright, so now we just have to multiply straight across. Now, if you notice, the 5 and the 10 do have a common factor, so we can cancel them. The 10 has a 5 in it, so we can cancel the 5, and that leaves us with a 2 here. And canceling the 5 up here, that leaves us with a 1. And now we can just multiply straight across. So this is going to be 1 times 3 over 4 times 2, or 3/8. There we go. And that's our answer, 3/8. Now, let's evaluate that on a calculator as well. Okay, so let's bring up a calculator. We have to be careful when we do this on a calculator. Remember the rule that we mentioned before in one of our previous videos. If you have a fraction and anything in the top or bottom is more complicated than just a single number, put it in its own set of parentheses. So in this case, we do have to evaluate this as parenthesis 5 divided by 4, close that off, there's our numerator, divided by, and our denominator, 10 divided by 3 in its own set of parentheses. There we go. And we get 0.375. That is 3/8. Just verify that. 3 divided by 8. And yeah, okay, and that's exactly what we got down here. Now, if you forgot the parentheses, you will not get the correct answer in this case. Notice if we evaluated 5 divided by 4 divided by 10 divided by 3 like that, well, you don't get 0.375, you get 0.0416 repeating. So you should follow that rule. If anything in your fraction, if the numerator or denominator is more complicated than just a single number, put it in its own set of parentheses. Now let's look at adding and subtracting fractions. Let's first of all look at when we have a common denominator. That's the easy case. If we want to add two fractions and they have a common denominator, notice that we have the b down here in the denominator of both fractions. Then all we have to do is add the numerators and divide by our common denominator. So a over b plus c over b is a plus c divided by b. And the same thing if you're subtracting. This would be a minus c divided by b. For example, let's simplify 5/3 plus 4/3. That's just going to be 5 plus 4 over 3. So that's 9/3, or just 3. Down here, subtracting, if we have 5/3 minus 4/3, that's going to be 5 minus 4 divided by 3, or just 1/3. So adding and subtracting fractions with a common denominator is easy. You just add or subtract the numerators and divide by the common denominator. Now, when a fraction does not have the same denominator, then you have to find a common denominator before you add. So for example, let's simplify 5/6 plus 4/3. Let's add that together. Now what we're going to have to do here, we're going to have to create a common denominator. Well, notice that if I multiply this 3 by 2, I will get the 6 over here. So we will multiply the 4/3 by 2 over 2. Notice we don't change anything when we do this because 2 over 2, this quantity is just 1, right? That's just the number 1. So when we apply our rule for multiplying fractions, and we get 5/6 plus 8/6, and so this is 13/6, and there we go. Let's look at this one, 5/6 plus 3. Well, now we have to think of the 3 as being 3 over 1. Now this one we can make a common denominator by multiplying the 3 over 1 by 6 over 6. And then this becomes 5/6 plus 18/6. And then we just have to add 5 plus 18. That's going to be 23 divided by our common denominator, 6. And there's our answer. So that's what you have to do when the fractions don't have a common denominator. You have to make one of them common. Now there's another rule we could follow for creating a common denominator, and that's called cross-multiplying. So this you'll see used sometimes. It's the same as finding a common denominator. What you can do is if you have a over b plus c over d, so the denominators are not the same, b and d are different, what you can do is you can multiply the a times d, indicated by this arrow right here. You multiply the a and the d, and you multiply the b and the c, and then you add them, so you create, so right here they are, a times d plus b times c, and then divide all of that by the product of the denominators, b times d. And so that's called cross-multiplying. And the same thing with subtraction, but you would have a minus here, so you'd have a times d minus b times c over b times d. Now this really is the same as finding a common denominator. It really is exactly the same. Down here is a little proof of why it's exactly the same as finding a common denominator. If you look at a over b plus c over d, to make the denominator common, you multiply the a over b times, you multiply that by d over d, and you multiply the c over d by b over b. Now the denominator would be bd, and bd over here, you see. That's exactly what we've done right here. And this is the same as a times d over b times d plus b times c over b times d, and now you just add the numerators and you get that. So cross-multiplying really is just finding a common denominator. Now let's look at some examples where we use it. So for example, let's evaluate 3/5 plus 7/4. Alright, so if we want to cross-multiply, then this is just going to be 4 times 3 plus 5 times 7 divided by 5 times 4. And that's it. That's all you have to do. And so what are we getting here? We're getting 47 over 20. And that doesn't simplify. These don't have any common factors in them, so we have to leave it as 47 over 20. Let's do this one. 3/5 plus 7. Now we have to think of the 7 as 7 over 1. And now we just do our cross multiplication. So we think of multiplying the 3 and the 1 together, 5 and the 7, and then divide by the 5 and the 1. So this will become 3 times 1 is 3, 5 times 7 is 35, divided by 5 times 1 is 5, and we get 38/5. And that's our answer. Notice that that is the same as finding a common denominator. We could have done this as 3/5 plus, now to make 7 over 1 common with the 5, we could write it as multiply 7 over 1 by 5 over 5, right? So we would get 35 over 5, and that's exactly what we have right here. 3 plus 35 is 38 over 5, and there you go. Let's do this one. 3/5 minus 7 over 10. Now here the problem says to find a common denominator instead of cross multiplying and verify that you get the same answer with cross multiplying. So let's find a common denominator first. So this would be, obviously this is pretty easy. We can multiply the 3/5 by 2 over 2 to make the denominator common with 10 here. So this would be 6 over 10 minus 7 over 10. And you get 6 minus 7 is going to be -1 divided by 10. And that's your answer. Now if you did do cross multiplication, let's put that up here. If you did cross multiplication, 3/5 minus 7 over 10, that would be 3 times 10 is 30, minus 5 times 7 is 35, divided by 5 times 10 is 50, and that is equal to -5 divided by 50. And now 50 and 5 obviously have a common factor of 5, so if I cancel the 5 here, leaves me with 1. A 5 in the 50 leaves me with 10, and we get -1/10, which is obviously the same answer. Let's take a look at this one. Let's simplify 5 over 4 plus 3 divided by 10 over 3 plus a half. So let's do this by hand and using a calculator as well. So, by hand, now if you want to try this one on your own, you can pause the video here. So, I'm going to start it now. Now you can either use cross multiplication or finding a common denominator, whichever one you prefer. I'm going to do cross multiplication. In the top, I think of this as 3 over 1 right there. So this is going to be 5, 1 times 5 plus 4 times 3, 12, over 4 times 1. So there's my numerator. In the denominator, 2 times 10 is 20. 3 times 1 is 3. Divided by 6. And this comes out to be, let's see, we're going to get 17 over 4 in the numerator, divided by 23 over 6. Now, to evaluate this, remember we have to flip this fraction in the denominator and multiply it against 17 over 4. So this becomes there we go. Now let's just check if we have any common factors in these numbers. Yeah, the 4 and the 6 have a common factor, right? 2. So I can cancel the 2 and the 4, leaving me with 2 here, and the 2 and the 6, leaving me with 3 up here. And so this becomes then 17 times 3. So that's going to be 51 divided by 2 times 23, and that is going to be 46. And there's our answer. Now let's just check that we can do this with a calculator or Excel. Let's do it with Excel for a change. Let's see, we just have to, well, we can just type it up here. We're fine. Alright, so make that a little bigger. So equals, now the numerator is going to have to be in its own set of parentheses. 5 divided by 4 plus 3, there we go, divided by, then the denominator in its own set of parentheses, 10 divided by 3, 1 divided by 2, and there we go. That's how we would enter it. You would do the same thing in a calculator as well, except you don't need the equal sign in front. And let's see what we get. 1.108696. Well, let's just check that that is the same as 51 over 6. So if we go equals 51 divided by 46, I said 51 over 46. And yes, that is the same number. All right, so that verifies that one. And that concludes our review of fractions.